Good day, everyone. I am Rhea from the YC group of BSEd Physical Science 2, and I am here to talk about force and motion. Everything in the universe is in motion, from the electrons in the atoms to the stars in the sky. Science has one goal, that is understanding how the world around us works. In this tutorial, we shall seek to analyze every basic question about the behavior of moving bodies. What makes a thing move when it's moving? Why do some things change direction? Why do others speed up, accelerate, or slow down easily? And why do others still move indefinitely at a constant velocity? This is all about force in motion. Let's define the two. Force is a push or a pull. In most cases, the connection between the force and the object is clear. What do you think will happen when you kick a ball or when you stretch a spring? The force that you exerted in kicking the ball is a push, and stretching the spring is a pull. What about motion? Motion makes the world go round. In fact, motion is important to our lives and a lot of impacts the many things that we do. Motion requires a force to cause that change. Forces produces a change in motion. This was described by Sir Isaac Newton in three laws. There are three laws that govern all objects in the universe. A body at rest will remain at rest, and a body in motion will continue to move at a constant speed in a straight line unless acted upon by a net force. We call this law the law of inertia. Let us consider a textbook resting on one end of a table. Once you apply the horizontal force, the textbook will move. The moment you remove the force you are exerting on the textbook, motion stops. Always remember that the tendency of a body to maintain its state of rest or of uniform motion in a straight line is called inertia. Without force, all objects here on Earth slow down only because of the force from air friction and air resistance. Let's proceed to the second law of motion, the law of acceleration. The acceleration of a body is directly proportional to the force exerted on the body and inversely proportional to the mass of the body. Newton's second law of motion can be written mathematically as force is equal to mass times the acceleration. This means that it's harder to change the mass of the object with more mass. This law implies when you step on the gas pedal of a car to increase its speed or bring it to stop by applying the brake. Do you remember the free fall motion of Sir Isaac Newton? Newton's second law of motion will be applied to analyze the motion of the object that are falling. Under such condition, all objects will fall with the same rate of acceleration, regardless of their mass. But why? Consider the free-falling motion of a 1,000 kg baby elephant and a 1 kg overgrown mouse. If a free body diagram were constructed, there would be a greater force of gravity. Let's take a look to the third law of motion, the law of interaction. In every action, there is always an equal and opposite reaction. The third law implies the two different bodies on two different forces. These forces are action force and reaction force. Action force is the force that one boy exerts on another, where reaction force is an equal force that the second body exerts on the first, but in opposite direction. The downward force exerted by the textbook due to its weight on top of the table. The chair exerts an upward force to support your weight while you are sitting in it. And measuring forces, do you know that the most commonly used force measuring instrument is the spring balance? To sum up this, force is just a fancy word for pushing or for pulling. If a person pushes on something or pulls on it, then it is applying force to it. Force makes things move, or more accurately, make things change their motion. My discussion will end here. Thank you for watching. I hope you learned a lot from this tutorial.